Okay, in today's video, we are going to discuss about terms and definitions of contact lenses. Okay, so what are the terms? What are the definitions of contact lenses? Basically, there are a lot of terms. Yes, we know a lot of terms, and the definition of that term is very important in contact lens education. So, this presentation is made by one of my favorite student, and I'm using this presentation to define all each term. So I think it's very important when you're going to start contact lens actually. Okay, so let's move. So what are the basic terms? So what do you mean a contact lens? So contact lens means ophthalmic lens designed to be worn in front of the surface of eye. Yes, and corneal contact lens or intralimbal contact lens. What do you mean by that? It means by the contact lens having total diameter less than the visible iris diameter. Yeah, sometimes we call SVIDS, horizontal visible iris diameter, and designed to be worn in entirely on the cornea. If contact lens actually sits on the cornea, then it's called corneal contact lens or intralimbal contact lens. Yes, sometimes we usually what do you call RGPs, but that's the wrong term. Yeah, RGP means the material, rigid gas permeable, but colloquially, or what do you call, which we call RGPs, but yes, it's actually termed as corneal lens. So scleral contact lens, what do you mean by that? It lands on the sclera, isn't it? Contact lens whose scleral zone supported on the bulbar conjunctiva. So that's why scleral lens is misnomer. Scleral lens do not land on the sclera, it lands on the conjunctiva, and we do not call it conjunctival lens. Yes, sometimes it's called misnomer, but I don't know. So whose optical zone over the cornea? Basically, yes, definitely optical zone we want over the cornea, but yes, that land zone, it lands on the bulbar conjunctiva. The terms such as miniscleral, semiscleral, corniscleral can be profound the contact lens literature to describe the lenses and different parameters. Sometimes it's very difficult. Yes, sometimes semiscleral, corniscleral is simple, lands on the cornea a little bit, and sclera a little bit, but miniscleral, semiscleral is depend upon the how much diameter it is, or yes, there are different classifications. Yes, sometimes like landing on the bulbar conjunctiva or above the sclera, that's why it's called scleral lens. So lenticular contact lens, we know it. Yes, lenticular means lenticule. Yes, contact lens having front optic zone made smaller than the total diameter. Yes, there is obviously always front optic zone is smaller, but overall optic zone is very smaller as compared to other contact lenses. Other contact lenses optical zones are larger as compared like 90% or 80 to 90%, but lenticular contact lens is not like that. Lenticular contact lens optical zone is basically uh, almost half of the area. Yes, almost, not exactly. So contact lens having front optic zone made of smaller than the total diameter. Front optic zone is always smaller than the total diameter, but in lenticular, yes, it's very small as compared to other contact lenses. So contact shell, what is contact shell? Contact shell is contact lens not designed to not designed to correct the vision. That's a contact shell. Okay, it's very important, not designed to correct the vision. Rigid contact lens in its final state under normal condition retain its form. Yes, what do you mean by retain its form? It is rigid, it's not warp into the cornea, and without a support it retain its shape, and it has water content less than 10%. It's very important, remember this point. Okay, so what do you mean by rigid contact lens? You must know it must be rigid, and it must rigid for retain its form, and it must have water content less than 10%. It's very important, we know it. So rigid gas permeable lenses, contact lens manufactured from the rigid material containing one or more gas permeable polymer in sufficient concentration to facilitate transport of oxygen through the lenses having decay equal to or greater than 10 decay units. So basically that's where we call it gas permeable. Okay, first it has to be rigid, then it has to be gas permeable, it has to have greater than 10 decay. So that's why PMMA we do not call as a RGP. PMMA is actually rigid material. It's not gas permeable material. Okay, so that's why we do not call PMMA as a RGP. We call PMMA rigid material, not gas permeable material. Okay, to say gas permeable, it must be greater than 10 decay, and at the same time it must pass oxygen. Yes, So soft contact lens, what do you mean by soft contact lens? Contact lens made by hydrogel material, okay, or non-hydrogel material, which in its hydrated final state, it's very important, or final state under normal condition contains known water content, and it's deformable and may not retain its form without support. Basically means it's wrap up with the cornea or conjunctiva, and it may not uh, retain its original shape. It's another important condition. And hydrated means in final state it must be hydrated and greater than 10% water content. Yes. So basically soft contact lens. So hydrogel contact lens, what do you mean a hydrophilic contact lens? Obviously, it love the water. Hydro plus philic, yes. So contact lens made of water absorbing material having equilibrium water content greater than or equal to 10%. That's another important concept. Less than 10% we call hydro, what do you call, it's RGP, yes, Focon. Greater than 10% is called what do you call it, hydrophilic, so we call Philcon, yes. Etafilcon, Galifilicon, Filcon, greater than 10%. If it is less than 10%, Focon, yes. In standard saline solution of a specific ICO, ISO, and at 20 degrees Celsius, that's hydrogel. It's very important to understand equal to 10% or greater. It's very important. Okay. So hydrogel contact lens. So composite contact lens composed of two or different material. Example: laminated lens, fused segmented lens, and lens with a rigid center and periphery. Flexible periphery is sometimes a hybrid contact lens. Yes, we sometimes called composite contact lens. It's just a term. So basic terms: bifocal. What do you mean by bifocal? It's multifocal contact lens having two optical zones, usually for the distance and the near correction zone. Remember, on the normal conventional contact lens zone, if it is contact lens completely, then the optical zone is decided by front optical zone diameter. Yes, and this is periphery zone, which are only supporting zone, not optical zone. But if from this definition, just remember, multiple contact lens means it have two or more focal zone, optical zones. That's what the bifocal means, two optical zones. Multifocal means two or more optical zones. It's very important. Contact lens designed to provide two or more zones of the different corrective powers. It's very important. Okay, so something like that. There are three designs in bifocal. Yes, first design is concentric design. What do you mean by concentric? If in this picture the yellow means near power and the other color means the distance power. Just remember the yellow and the other color, which is this color, yes, is centered commonly in one center, which is this. That's why it's called concentric. And in this particular, that's we can make center distance center near, but at the same time sphericity is the main optical element. What do you mean by that? It means by, oh yes, center is steeper and periphery is flatter, or center is flatter, periphery is steeper. So we make either prolate or what do you call, oblate optics. So sphericity will give the power, whether near will be much more plus or distance will be much more plus. It depends upon that. So that's called aspheric uh, design. And another is translating, which is commonly like glass. Yes, it's commonly found in a rigid glass and a rigid contact lens. Distance is the upper portion is distance power, hold distance power, and near portion hold near power, and it's basically translating uh, bifocal contact lens, which depend upon the translation when patient look at near. Yeah, so that's it. So progressive power contact lens or varifocal power contact lens. What do you mean by that? Contact lens designed to provide correction for more than one viewing range, in which power changes continuously rather than discrete over the part of the whole, over the part or the whole contact. It's basically like the progressive spectacle, isn't it? So it's not like transition discrete, it's not like translating, it's not like something like that. Yeah, it's like there is a change progressively in contact lens. So that's what we call progressive contact lens. Another term is varifocal power contact lens. Yes, it's something like that. See in this picture, so first this ring is first ring is for the near, yes, and then adjacent intermediate ring is for the intermediate distance, and then the most peripheral ring is for the far distance. So, and these three things progressively changes in contact lens, not like abruptly changes, and that's why it makes progressive contact lens. Okay, so terms related to contact lens parameters and designs. Let's discuss about it because it's very important. Yes. See, these are the pictures, and I have taken this picture from the book Contact Lenses by Philips. Yes, you must understand this picture first, and then slowly you understand other point of view. For example, see one contact lens axis. This is the line for contact lens axis. Yes, second center of the vortex sphere basically means two. This is the center of the vortex sphere. What do you mean by vortex sphere? Means by this sphere. Yes, center of the vortex sphere. Back vortex, what do you mean with 3? Back vortex is same thing what we are discussing, center of the vortex sphere. The back vortex means this is the back vortex. Yes, because as a spectacle there is back vortex. 4 is a vortex sphere. Remember, this will come later on. Vortex sphere means if you draw this vortex back, basically base curve. Yes, this is base curve, isn't it? If you draw base curve into the circle, then this circle is called vortex sphere. Yes, we draw this basically a circle. Another point which is important point is, see, fifth, peripheral junctional thickness. What do you mean by that? The point 5, the junction, first curve, back curve, and the base curve, and the first periphery curve. This is junction. Yes, and the thickness of this junction is fifth point. Yep, yeah, got it. And then overall posterior sagitta. What do you mean by overall posterior sagitta by 6? See, sagitta means this is the chord. Yes, from this is the distance. Yes, this is the chord, and the distance, basically sagittal depth. Yes, this is 6 number, isn't it? This is same thing. Yeah, whether this or whether this is the same thing. That basically means posterior sagittal depth is 6. It's very important that you understand each point. Okay, and then definitely there is a phi naught, phi 1, phi t. Basically phi naught, what do you mean by phi naught? What do you mean by phi t1? And what do you mean by phi t? Yeah, phi means the distance. Yes, phi means the diameter. It's always there. So what do you mean by phi naught, phi? And there another term, r naught, r1, and r2. What do you mean by that? It's very important. Yes, first you must understand these few points, and then it's really important to move further on the points. That's something important. Can you see here? It's r naught means radius. Radius of what? Radius of base curve, isn't it? So r naught is actually base curve. Yes, r1 is the radius of first periphery. So it must be r naught is steeper than r1 because r1 is flatter than r naught, isn't it? R naught is steeper than r1. R1 is larger. Yes. What do you mean by r1 is larger? Which r1 is flatter. Then r2. Why? Because r2 is most periphery. Most periphery is always flatter than any other two. Yes, it's a tricorn contact lens. So why this is the thing? Because contact lens cornea itself is prolet shape, because cornea center is steeper, periphery is much flatter than center. Yes, to make contact lens fit with the cornea, contact lens must be steeper at center and flatter as it goes to periphery. It's always there. But what happens if R naught is flatter than R1? That's where we call it, what do you call? That's where we call it reverse geometry contact lens. Okay, reverse geometry. contact lens, because it's not like regular stuff. R1 is steeper than R0. It's called reverse geometry, Steve. What do you mean by that? This back curve is steeper as compared to our base curve. Yes, and R1 is steeper than base curve is called reverse geometry. You will see this in orthokeratology, isn't it? Reverse geometry, and you will see this in, uh, I think, in penetrating keratoplasty cases. Yes, reverse geometry will be better. So basically, why we call it a reverse geometry? Because normal is this: R1 is greater than R0, R2 is greater than all. But if there is second curvature is more steeper than the first curvature, base curve, it's called reverse geometry. You will see this case a lot. Yes, yeah. So I think I have introduced a good way this all these things. Then I think I have to stop here for today. Then I will definitely start in definitely going to tell you mm, this Tom and a lot of things in second video, because there is a lot of things we have to cover in second video, because it's already 16 minutes, so I have to stop here. Okay, so it will definitely come back. Okay, so I think Bistan choose.